Okay, so at the top of the paper that you see your amplitude we just talked about. You know how to find your B value, which is using your period. C is the shifts, the left and right, our phase shift, and then D for that center line is your vertical shift, okay? So now we're going to work through it's called a motion problem, okay, because you'll notice that it's going to have a sine or a cosine function, okay? So we have a person is riding a Ferris wheel. Sam uses a stopwatch and notices that a person is at the highest point at 80 feet above the ground. So, if this is my height, okay, and down here is going to be time. We'll just say t. So, he's 80 feet above the ground when t equals 3 seconds. So, 1, 2, 3, he's about right here. All right, when t equals 7 seconds, the person is at the lowest point, which is 20 feet above the ground. So 1, 2, 3, 4, 5, 6, 7. So if I'm counting by that, I'll just do 20 at 7. Okay, assume that the height of the person above the ground varies sinusoidally with time, so meaning it's going to continue. All right, so we have the highest and we have the lowest. What can we do with that?
You can connect them.
You can find the amplitude. We also can find the what. That gives me one more point.
The D.
The center line, exactly. So my max, exactly. So I have 80. Well, no. If I do the center line, it's plus. 80 plus 20, which is 100 divided by 2. What's my center line? 50. So that means at 50, I'm right here. And what's that time? If I have 2 to 7, where is it?
5.
5. Oh, no. I said 2 to 7. I meant 3 to 7. So we're at 5. So if we sketched a cosine graph, it would look something like this. And we know it's going to continue that way. All right, so write a trig equation for the height above the ground for the function, or in terms of time. All right, so we have our center line, so we have our D value, our plus 50. All right, so we need amplitude, and we know amplitude is going to be 80 minus 20, which is 60 divided by 2, so we get 30. And what's the other thing we need to know? Say it again.
Period.
The period. All right, so what is my period when you look at this? So from 3 to 7, we have 4. But
So it's pi.
times 2, right? Because this is only half of a sine function, or a cosine function. I need to go back up another rotation for it to be a full one. So it's 2 times 4.
So it's 8.
It's 8, okay? And that equals 2 pi over b. So when you multiply b from both sides to get it out of the denominator, you have 2 pi divided by 8. So b equals pi over 4. So my function, I'm going to write it right here. Y equals, I don't have room down here, so why don't you put it down here? This is where it belongs, but I'm going to write it up here. All right, my amplitude is 30 cosine, because I'm above here. I'm above at my max. My b value is pi over 4. We need to adjust our shift, but then we have plus 50, because we know that that's our center line. Can you see that over there? All right, so from 0, how many? I shifted to the right, so I'm going to have t minus, but t minus what? 3, because that's how many I shifted. All right, so I'm going to leave this screen up, but I'm going to answer the bottom two C and D, okay? So C says, what will be the height above the ground of a person at 11.5 seconds? So what did I give you? Did I give you Y or did I give you T, since we're using this? I gave you T, so what do I do?
Just plug in T.
Yeah, plug in 11.5 for T. Use your calculator, make sure you're in radian mode. Radian mode, you might want to write that down if you think you'll forget. And when you plug this all in your calculator, and t is 11.5, and you put it in just like this with parentheses and everything, you're going to get 77.7 feet. And I think I rounded that last one. Okay, so that's the answer for C, 77.7 feet. Now, logically, your answer needs to make sense. It needs to be in between what two values? Not 0, because I don't really want to be in a Ferris wheel that hits the ground.
20 and 80.
20 and 80. Okay? So, is it in between 20 and 80? There you go. Alright, so find the first two times greater than 0. So, you're starting at 0 and then looking to the right. When the height of the person above the ground is 70. So, what did I give you? Height or time? Say it again. I gave you height. Can you see here? All right, so that means I have 70 equals 30 cosine pi over 4 t minus 3 plus 50. Okay, so now I'm setting it equal to 70. So this isn't the easiest thing to solve, but we're going to solve it graphically. So what you first need to do is you need to graph it. Okay? And you need to set your window accordingly. You can count by radians in your calculator, okay? So go ahead, try to plug it in and adjust and make sure you can see it, okay? You know that we're counting by, well, we're counting, I guess, by here by ones. And then you need to go up to 80 to see the whole thing. Now, you can start, though, your x interval at 0, because it says including 0, but everything above it. So when you do that in your calculator, do you remember when we found intercepts of any other function? Like second trace number 5, intercept. You need 2 lines to have an intercept. So what's the second? If this is my first function, so I have y1. Here, I'll write it like this. This is y1. What is y2 in my calculator going to equal? Say it again. 70. So this is the function I want to graph. And then I want it to equal 70, so where they intersect, that's what I'm looking for. Now, 70 is like here, right? So if this is going to continue, it's going to hit it infinitely many times. But I gave you a restriction. I said starting at 0 and above, so there's your first restriction, and then it says find the first 2 times. So I want to hit it here and here, so on the way up and on the way back down. And when you do that, all right, so you go to calc. So second trace is calc, all right? And then you hit number 5, which says intercept. You take your cursor and you go over to that intersecting point as close as you can. You hit enter 3 times. It's going to say first curve, second curve, guess. Enter 3 times until at the bottom it says intersection, and it gives you that point. And the first one is at t equals 1.93, and we're dealing with seconds. And then you have to go back and do second trace number 5, enter, 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 a second time. You just have to move your cursor over to the second one. So every time you want to calculate something like that in the calculator, you have to go back through the motions of pressing all the buttons. So your first one's at 1.93, and your second one is going to be at 4.07 seconds. So the big key to this is knowing, okay, I have a function, this is what it represents. In this case, it's a Ferris wheel. Am I giving you time? Plug it in. Am I giving you the height, the y value? You need to graph it. You need to see it. You can't do second trace. You can't calculate the intersection if you can't visibly see it on your screen. So you have to adjust your window to see it. And then you just figure out exactly what it's asking for. If I said 0 to everything above it, but I want the third and fourth one, you have to note that and make sure that that's the one that you're giving me, so that we all have the same answer on our paper. Any questions? Okay.